Hi there. Let's talk about functions. Functions are a very important concept in mathematics, physics, engineering, chemistry, the sciences. They're incredibly important. And what they do is they're a way of transforming one type of quantity into another kind of quantity. So let's just name a few examples. Suppose you were a manufacturer, you're manufacturing chairs, right? So you want to know how many chairs should I produce in order to maximize my profits. If I produce too few chairs, I won't have met demand. I could have made more. I could have made more money. If I manufacture too many chairs, maybe I'll have too many chairs to sell. Maybe I've spent too much in the process, the manufacturing, and employees and the time, and I won't make as much money if I make too many. So there's a sweet spot there. How many chairs should I produce in order to maximize my profit? And so what we need here is a function that transforms number of chairs into profit. One quantity into the other quantity. So that's one example of a function. Another example of a function would be, how about we take an object like a ball, right? We toss it into the air. Right. Now, what did it do? It went up and came back down. I might be interested, as a physicist, I might be interested in knowing how high was that ball at any point in time. Well, what I'm looking for is a function that transforms time in seconds to a height in centimeters. That would be a function. Finally, one other example would be, suppose, so I'm from the US, I'm traveling to Europe, and when I get there, they're going to be talking about the temperature in Celsius. Well, in the US, we talk about temperature in Fahrenheit. So what I'd like to have is a function that converts Celsius temperatures into Fahrenheit temperatures. So can I find such a thing? Can I find a transformation that takes a number in Celsius and transforms it into a new number that is in Fahrenheit? So those are some examples of functions. So when we talk about functions, what we're going to do is we're going to look at them in two different ways. We're going to think about them algebraically, and we're going to then think about them graphically. So let's start with the algebraic approach, and we'll take a look at that the last function I mentioned, converting Celsius to Fahrenheit. So to talk about functions from an algebraic perspective, we need to talk about function notation. Function notation first requires us to come up with a name for our function. Well, we can give it any name we want, but most commonly you'll see the name f, just a script f. But you could call it G or H or any other letter, or you could call it George. You could represent it by a smiley face. Really, as long as you define it to be something, some symbol that you're going to recognize going forwards, that's fine. But usually we're going to use script f, f for function. Secondly, we're going to need a variable to represent the input of the function. So very often the input variable will be represented by x. X is a very common variable to use in mathematics, so why not use it here? But don't be surprised if you see other variables used in place of x, different letters. That's okay. Now our function takes an input and produces an output. So we need to have some way of writing down the output of our function. So what is the output associated with the number x? Well, the way we write this down is as follows. We write f with parentheses next to it, so the name of our function with parentheses, and then we put the input into those parentheses. It's as if those parentheses are a receptacle for our input. We put it in there, and the function chews it up and produces the output, kind of like a machine. It takes one thing, you plug into it, it chews it up and produces something else. So our function f has been fed the input x, and this is how we denote the output. Okay, well, this is all very abstract. So let's see how this applies to the example that we talked about relating Celsius to Fahrenheit. All right, well, if you ask an expert, they'll tell you the algebraic relationship between Celsius and Fahrenheit. They'll tell you that it is as follows. F equals 9/5 C plus 32. Capital F represents Fahrenheit, the temperature in Fahrenheit. Capital C represents the temperature in Celsius. So if I just take the temperature in Celsius, multiply it by 9/5, add 32, it will produce the temperature in Fahrenheit. So how do I write this in terms of my function notation? Well, what I would do is say, well, let x represent the temperature in Celsius. Then the Fahrenheit temperature is given by f of x. So I'm using lowercase f to represent the Fahrenheit temperature, and this is the Fahrenheit temperature associated with the particular temperature in Celsius, which I'm letting be represented by x. And we know that to get Fahrenheit from Celsius, well, it's given by this algebraic relationship here. It's going to be 9/5. Now in this case, my Celsius temperature is x, so I'm going to put the x there. And there we have it. This is the function that transforms Celsius into Fahrenheit. Okay, so let's use this to compute some conversions between temperatures in Celsius and Fahrenheit. All right, so let's take a look at some examples here. Let's take a look at what would the Fahrenheit temperature be when the Celsius temperature is 0? Well, what I'm interested in is f of 0. Remember that x represents the Celsius temperature. If I say the Celsius temperature is 0, I'm going to put 0 in place of x. Well, I happen to know that this is equal to this algebraic expression, so I'll just put 0 in place of x in that algebraic expression over here. And look at this. 9/5 times 0 is 0, plus 32 is 32. So the Fahrenheit temperature associated with 0 degrees Celsius is 32. What about the Fahrenheit temperature associated with 10 degrees Celsius? Well, since this is given by this algebraic relationship, I'll just put 10 in place of the x. So 9/5 times 10. Well, the 5 goes into 10 twice. 9 times 2 is 18. 18 plus 32 is 50. So I know that the Fahrenheit temperature associated with 10 degrees Celsius is 50. What about when the Celsius temperature is 20? Well, that's going to be 9/5 times 20 plus 32. Well, 5 goes into 24 times. 9 times 4 is 36. 36 plus 32 is 68. So the Fahrenheit temperature associated with 20 degrees Celsius is 68. Let's just do one more here. What's the Fahrenheit temperature associated with 100 degrees Celsius? Well, it's 9/5 times 100 plus 32. Well, 5 goes into 100 20 times. 20 times 9 is 180. 180 plus 32 is 212. You might know this from chemistry, that the boiling temperature of water is 100 degrees in Celsius. The boiling temperature of water is 212 degrees Fahrenheit. Now here's a little puzzle for you to think about. What temperature is the same when measured in both Fahrenheit and in Celsius? And how can you show how to find this temperature mathematically? How do you use mathematics to find that temperature that is the same number in Celsius and in Fahrenheit? A little puzzle question for you.